¿Listo, Dani?
Adelante.
Muy bien. Buenos días a todos y todas. Les agradecemos mucho su presencia. Estamos aquí en una continuación de una serie de conferencias que iniciamos en noviembre de 2020 sobre nuevos datos, nuevos métodos para generar información oficial. Simplemente dar la bienvenida agradeciendo su presencia por parte del INEGI, por parte del TEC de Monterrey. Vamos a hacer esto en inglés, normalmente lo hemos hecho así, por lo que tenemos algunas personas que solo hablan inglés y quisiéramos que también participen. Entonces, welcome to you all to this series of conferences that we initiate in November 2020. The name of these conferences is New Data and Methods for Generating Official Information. So let me just give the floor to Grisel Ayllón. Thank you.
Thank you, Ricardo. Thank you, everyone. As you just said, INEGI and TEC de Monterrey are very pleased to have you here at this third day of sessions of the conferences about new data and methods generating official information. We have heard very interesting talks about macro forecasting, health economics, tracking the economy under lockdown periods. And today we are going to hold a different topic, public safety and crime perception. To start this session, I will introduce our speakers, Juanjo Medina and David Buil-Gil. Juanjo Medina is a Talentia Senior Distinguished Researcher affiliated to the Department of Criminal Law and Crime Sciences at the University of Seville. The Talentia Senior Scheme is a program of the Andalusian government aimed to attracting and retaining researchers with an excellent scientific and leadership curriculum. Previously, he worked as a full professor of quantitative criminology and the head of the Department of Criminology at the University of Manchester until August last year, 2020, where he taught data analysis and crime mapping skills to criminology students in September 2000. He was the president of the Spanish Society of Criminology from 2016 to 2020. His interests are gender violence, crime prevention and policy, urban crime, quantitative methods, and environmental crime. He studied 2 PhDs, one in criminal justice at Rutgers University and one in criminal law at University of Seville. I strongly recommend Juanjo's webpage, as you will find it useful material, databases, books, art codes, and several information in the theme of crime. Meanwhile, David Buil-Gil is a researcher fellow in cybercrime at the Digital Trust and Security theme of the University of Manchester. His research areas cover geographic criminology, small area estimation applications in criminology, crime mapping, measurement error in criminological research, emotions about crime, perceptions about the police, new methods for data collections, and open data. He obtained his PhD at the University of Manchester in December 2019, and in his PhD research, he applied model-based small area estimation techniques to criminological research in order to produce estimates and maps of confidence in police work. Currently, he is member of the board of Spanish Society of Criminology Research, coordinator of the SAIC Working Group of Quantitative Criminology, and a member of the board of the Spanish Network of Early Career Researchers in Criminology. I think they will present us the conference, Small Area Estimation from Survey Data Applications in Criminology. And correct me if I'm wrong, but I've learned that this is part of your work, David, at your thesis, that Juanjo was supervising you, isn't it? Yes, so we are going to listen about this theme. And well, we were just talking about the crime. Crime is surely one of the most difficult themes to study, as relying on official data might not necessarily be an accurate measure. Just thinking about the Mexican case, where it is estimated by the National Criminal Observatory that around 92% of the crimes are not officially reported at the police stations. So one analysis technique that has shown very important advantages is related to geographical references. In other words, or in the words of our presenters, small area estimation techniques borrow strength from related areas to produce reliable small area estimates. So Juanjo, David, we are very welcome to have you here. I will be collecting all the questions, please, for the audience. I will be pleased if you write down in the chat all your questions. I will gather them. So after 30 minutes, I will start reading them to open the discussion. So welcome once again, and the floor is all yours.
Okay, so can you hear me?
Yes.
Yes, okay. Well, first of all, I want to thank the organizers for having invited us, both me and David. We are certainly delighted to be here in what looks like a incredibly well-organized and well-selected, organized list of presenters. It is a shame that we cannot be physically there with you all. Those who know me know that I have a very soft spot for Mexican food. So I highly regret not being able to have this opportunity to visit you. Start by saying, you know, imposter syndrome is sort of common in academia. And when I saw the theme of the series, I felt a little bit like that, because we're not really going to be talking about new forms of data. We're talking about all forms of data that we're trying to exploit in ways that help us to address some of the issues that we also try to address when we use new forms of data. That is the limitation of existing data sets. And that's fairly pertinent in the area of criminology for some of the reasons that Gris was mentioning before, and that we're going to get a little bit deeper on during the presentation. So just very briefly, I mean, what we're going to do during the 20 minutes that we have allocated, we're going to provide you, give you a little bit of background as to why this is important. Then David is going to talk to you about the basics of a small area estimation. And then we're going to discuss a couple of the applications in which we have applied some of these kind of techniques within the context of criminology. And maybe in the final remarks, we'll tell you a little bit about the kind of things that we're planning to do in the future to take this forward. So why we need small area estimates in criminological research? There is a long tradition of research within criminology that is interested in the geography of all things crime related. You know, that area of research is typically referred to as environmental criminology. And one of the things that we have learned from decades and decades of research on this is that crime tends to be concentrated in a small subset of places. We know that so much so that people talk about the low crime concentration at place. Most crime tends to take place in just a few locations within urban environments, and criminologists have devoted a lot of attention to try to develop theoretical explanations to account for why this happens and what are the kind of features, both social and structural and architectural even, that can help us to understand this geography of crime. Now, part of the problem of traditional research on this is that it's, for the most part, have been relying on the use of crime recorded data from the police. And as we will see, that is problematic. The fact that the police and other criminal justice agencies is now using this kind of very fine detail set of maps of crime, you know, based on their administrative data sets for the purposes of allocation of resources and prevention, makes this even more topical and important. Surely you might have come across concepts such as predictive policing or hotspots policing. Perhaps you are a criminologist, more so the latter than the first one rather than the latter. But this is basically the idea that, you know, we can use information about where crime was distributed in the past to make decisions about where we're going to send our police and preventative resources. And as I said, you know, this is an issue because we know that, and we have known for a very long time, in fact, that police recorded crime offers a very incomplete picture of crime and of the geography of crime. Gris was mentioning earlier figures from Mexico, which I didn't know myself. Some of the data that we have from England and Wales and we have worked with talks about slightly smaller problem, but you know, we're still talking about 50% of the crimes not known to the police. And in data that we are now working with from the city of Barcelona, we know that in that city, on the metropolitan area of Barcelona, only about 20% of the crimes are known to the police. And of course, the issue here is that the missingness, right, is not random. There are personal attributes of people that make them more or less likely to report a crime to the police. And we know that there are also important attributes of neighborhoods and communities that are associated or correlated with these reporting rates. And that makes it even more problematic than to actually take at face value the maps that the police produce to justify their allocation of resources. So, and I mean, I've been just talking about one part of the problem, which is, you know, the problem with administrative data to understand the geography of crime. But of course, criminologists not only want to know where crime takes place, they also want to know why it takes place in certain places. And that means that we need to have information and measures about social processes that are relevant for the theories that we use to explain crime. And typically, administrative data is very sparse in this kind of data. I mean, you know, you can go to census data and you can go to other new forms of data to try to get information about these other processes. But very often, this information is only available from surveys. And the problem that we have with surveys is that surveys that measure crime, like victimization surveys, or that measure some of these theoretical concepts, are surveys that are done at the national level and that have samples that have been designed to produce, to allow you to make valid inferences at the national level or at best at the large regional level. But if you start going down to the level of, you know, small neighborhoods within cities, you might end up in a situation where you don't really have many cases within those particular segments of a territory to allow you to make valid inferences about what's happening there. So that's where smaller estimation techniques can be helpful to solve this problem. Now, David?
Yeah, I don't know if maybe I should share my own screen to make it easier, or that's gonna make things more complicated than that. Let's see. All right. So, well, again, thank you very much for the invitation, and thank you, Juanjo, also for presenting the first slides. Now I'm going to introduce what these techniques are and how they work in practice. The first thing that I should say is that this can be applied to mostly any variable recorded in surveys, right? Like, of course, we are criminologists and we're interested in analyzing different variables of interest for us, and which can be the dark figure of crime, for instance, that we will present an application later, and worry about crime, confidence in policing, and so on. But these methods have not been developed by criminologists. These methods have been developed by people interested in many different areas. So one of the benefits of presenting this approach outside the criminological theory is that it can be applied to many different areas. So let's start defining what's a small area in a small area estimation. A small area is any area, like geographical area or domain, for which we cannot produce direct estimates, let's say, a weighted mean, and with adequate precision. So we have surveys that have been designed originally to record representative samples or large samples at different geographical scales, but then when we want to produce estimates at very small levels of analysis, that can be areas, but it can also be social demographic domains, and we have very small samples, and then our estimates become not reliable. And that's what we define as a small area. And that's when we need small area estimation to produce estimates in those areas that we define as small areas, and because they don't have samples large enough to allow for reliable estimation. And then we want to produce still estimates of adequate precision in those areas. So the objective of small area estimation is to produce reliable and precise estimates of our parameter of interest in those areas or domains where direct estimates are not reliable enough. And we specifically make use of so-called indirect or model-based small area estimation. Since based on the sampling design in our areas of interest, the sample is too small to produce direct estimates, weighted means of adequate precision, we need to use indirect small area estimation using regression models. And we will explain how we do that, but the main definition of model-based small area estimation is approaches that borrow strength from related areas in order to improve the reliability of our estimate in each of our areas of interest. And we will present very, very briefly how this works, at least how the ones that we use, because there are many techniques in small area estimation, how the techniques that we use work and how we have applied them in different domains. Also, I forgot to say that one of the main benefits of using these approaches is that you can calculate you can estimate your measure of error for each of the estimates that you calculate, and therefore you can know in each area and in each time period, for instance, how reliable is your estimate. And therefore, when you can use this type of estimates for policy making to test your theories, etc., and when your estimates are not reliable enough to be used in practice, for instance. And that happens all the time. In some areas, we will be able to produce reliable estimates. In some areas, we will not be able to produce because our models don't work well in all areas, or our samples are too small even to allow for reliable model-based estimation. And I will just say very briefly that there are two main techniques in small area estimation: unit level and area level. Very easily, when we use unit level models, it is when we have information for every single individual in our sample, but also in the population coming from the census. And we can estimate our models at the level of individuals, but this is of course very difficult to access census data. And for instance, for every single individual living in each of the areas. So that's why we, in practice, many times end up using area level approaches, especially in applied small area estimation, right? We have many papers in theoretical small area estimation developing methods saying that unit level approaches tend to work better to produce reliable estimates, but in practice, and those who apply these techniques like us, we need to find reliable covariates for our models, and those covariates are usually published at the level of areas. And that's why we mostly use area level approaches in small area estimation. But again, we always need to say that we know that unit level approaches for small estimation tend to work better to producing reliable estimates. So if we have access to the census at the individual level, then we should be using unit level models for this approach. Now, I will present again very briefly the main approaches that we have used using maps. I will not present any notation, and so we at least know the differences between the main approaches. Since Juanjo and I are both Spanish, I will use a Spanish map, and we will imagine for a moment that the colors represented in the map show something, right? We have a theory that says that the color of these regions is correlated with crime, and therefore we will use the color of areas to borrow strength into our model. We will see how we do that. So, but the first step is always to compute direct estimates. We have a sample in Comunidad de Madrid of 12 people sampled. We obtain the weighted mean or the mean, or we use resampling techniques to improve a little bit the representativity, but still we only use the sample and we compute an estimate. Of course, this estimate will not be very reliable. That's when we need small area estimation because our sample is very small. So the first ones to present a method for area level small area estimation were Fay and Harriet in 1978, which basically what they do is calculate the direct estimate in Comunidad de Madrid coming from 12 citizen sample, and then estimating a model that combines our direct estimate with some covariates that we know are associated with our variable of interest. And in this case, our theory says that the color red is very important for predicting our parameter of interest. So we estimate a model with color red predicting the number of crimes in the area, and we borrow strength from it. Now, how do we do this in practice? We have a direct estimate, the weighted mean, which is 0.3. But we also know the measure of reliability of this direct estimate. We can say is the standard deviation, which is 0.1. But we also have some information about the area. We know that around 50% of image is 43.2, and the index of multiple deprivation we can say is 0.4. Again, this is all theoretical. We estimate a model that using those variables to predict our direct estimate, a linear model, and we obtain some regression parameters. With these regression parameters, we can calculate what we call a synthetic estimate, which is a prediction coming from the linear model. Very easy. We calculate our synthetic estimate with the intercept plus the regression coefficient for males times the number of males in the area, and we can do this for as many covariates as we want. And then we calculate our synthetic estimation in each area. But this synthetic estimation is very much dependent on the model, so it will not be reliable in every single area. So what we do in practice is combine direct estimation and synthetic estimation in each area, and we give more strength to one part or the other depending on how reliable the direct estimation is in each area. In some areas we will have very large samples. In other areas we will have smaller samples, and therefore we will need to give more strength to the synthetic estimation. That's how it works in practice. And then we can try to improve our models a little bit by adding temporal random effects and also spatial random effects. And that's what we have been doing in some applications in criminology. In terms of software, we use R, and there are two main R packages for that. SAEM, which has loads of functions for the main small area estimation approaches, and SAE2, which is used for temporal models in small area estimation. But we also use other packages that we can describe later. Now, we have applied this to different problems that we had in criminology. We wanted to know how different variables distributed at the level of small areas in our field, so we started applying those methods and to know how they apply, how they perform. So the first thing we wanted to know is whether the spatial IBLAB, which is including spatial random effects in the IBLAB that I presented before, how it works in criminology. So we conducted a simulation study in London showing that this approach is adding a spatial random effect to our models tends to work better when we are dealing with many areas. This is the measure of relative root mean square error, and this is the measure of relative bias. So these approaches tend to work better when we have many areas in our study, but also when the level of spatial autocorrelation becomes closer to -1, or closer to 1, as you can see. This is the difference between the reliability of the estimate coming from the traditional IBLAB model or the model that adds the spatial random effects. And so we applied this to data from the Metropolitan Police Service Public Attitude Survey 2012 to estimate overall confidence in the police at the level of small areas using different covariates, and then we could produce a map of confidence in the police in London with highly reliable estimates, because we again present the measure of mean square error of each estimate in each of the areas. After that, we were contacted by the Metropolitan Police of London to continue developing estimates of other perceptions about the police, also at the level of small areas in the city of London. Yeah, Juanjo?
Okay, so another application that's of the various that we have used here has actually been focused on the main issue that we were discussing at the outset, the problem of the dark figure of crime, that is, of the distribution of reporting crime to the police. We know that in England and Wales, this proportion of crime that is known to the police has remained fairly stable over the years. It doesn't necessarily have to be the place. I mean, I know data from the National Crime Victimization Survey in the States where there is a little bit of more fluctuation in terms of how this works, but at least the data in England and Wales seems to be quite stable. So we have that nearly 60, a little bit more than 55% of crime is unknown to the police. And the circumstances that the police come to know about crimes, for the most part, this is because the victims reported directly to the police. This tends to happen in about 60% of the cases. The second more common scenario is when a third party report this to the police, and more rarely this is to do with the police finding out by themselves or in some other way. So what we wanted to know, and this is important, as I said, because of the way that the police is using maps of crime to distribute resources, is to what extent, this thing that we see at the national level, whether there is significant variation once we start going down to a larger scale, once we start looking at local authorities and smaller areas. So we run again a small area estimation model. In this case, we added the additional feature of running this not only with a spatial component but also with a temporal component, and we could observe that indeed there is significant variation across the level of geography that we could examine in the special models. We were using MSO8, which is a particular census unit used in England and Wales, which points to the fact that indeed there is this variation and that there are attributes, some of which have to do with socioeconomic features of this area, that to a significant extent explain this variation in crime known to the police. So these are just a couple of the applications that we have used, but there are many others that we have explored in the bibliography that you'll see in a second. You'll see direct references to some of these. I mean, we think that clearly there is so far that you can go with these techniques, and it's important to use also other new forms of data to complement this. And I know that Reka is going to be talking later about some of this, and she will be able to expand in some other approaches to this. We still think that this is an important tool that hasn't really been used very much in criminology before David started working in this area, and I think that it's important that we continue using it because there is a lot of potential here, particularly not only in terms of understanding the limitations of official crime data, but also in terms of understanding those other processes or perceptions or attitudes that are relevant to criminologists. And our work has also suggested that it's important to incorporate this kind of spatial elements as a way to improve the reliability of our estimates. One of the things that we haven't really talked about, and that was kind of like the frontier of some of the work that we did, is that some of these small area estimation techniques, when we started working on this, weren't really optimized to work for situations where you have highly skewed distributions. And we know that victimization is a very highly skewed distribution. Very few people are victimized, and some of these people are victimized multiple times. So new techniques have come into play in the last few years, and we're hoping to actually exploit some of those in some work that we're working on at the present moment. I'll just leave you here with the list of publications that are related to some of the work this area. I think that we will finish here now.
Juanjo, David, thank you very much. We have different type of questions, questions more methodological and some other questions more of public policy and things about data collection. So let me start with I will not read in order the questions, but I will gather them by type of subject. Because I have here, like, countries like Mexico are complex and full of crime, and there are whole villages captured by crime and through fear or economic captivation. Hence, villagers protect crime itself, and it would be very difficult to obtain reliable data out of different sources. Given that, how could you estimate, or how could you use your methods to be able to study this type of environment?
Well, I mean, smaller estimation techniques work as far as you have social survey data that you trust. Of course, I mean, the problem that you raise is an important one. I mean, survey respondents have to trust a survey organization, have to be able to provide accurate information about crime. If you have that kind of measurement problem where you're not getting your villagers or your community residents talking openly about these things, then you're gonna have a problem. I mean, having said that, I mean, there's been this kind of perception from people that haven't really done criminological research in the past, that people are reluctant to talk about what happens in their communities, that they're afraid, that they don't, that crime is an incredibly sensitive topic, and that people find it hard to talk about it. The experience of criminological research says otherwise. I mean, people love to talk about these things. I mean, I can appreciate that, some of the situations in the villages that you might be talking about in the context of Mexico are particularly extreme in some ways, and those issues of trust are going to be present there. But I think that it would be worthwhile at the least try to do some sort of pilot studies to see whether you can gather this kind of data and then take it from there. I don't know if David wants to say something else.
And
just to add that that's true for the outcome measure, but in the case of covariates, like the basis of smaller estimation is having good covariates, and of course, if you don't have a good census that you can trust in the area where you want to produce smaller estimates, then your whole approach cannot be used, right? So even though our outcome measure can have different types of problems related to the source of data, we still, like, the most important part is having good covariates in smaller estimation. So without a good census, it cannot be used.
Thank you both. And then following question to that is, what could be the main contributions of this approach in terms of public policy design?
Well, I mean, because there are many applications, right? I guess that there are many possible answers to that. I mean, just to illustrate the kind of, I mean, to follow up from two examples that we have used. I mean, in terms of the second one, I think that it should help police organizations and criminal justice practitioners are using these kind of maps of crime to drive their policies, to be a little bit more cautious about, trusting what those maps show them. And, potentially you could adjust some of those maps with information, with the kind of covariates that we're using to produce this in the estimates. In relation to the other application that we were talking about, which tries to map out at the community level perceptions of the police, this is incredibly helpful as well, because it provides quite a small area kind of information about the perception of the police, that the residents of the police in particular areas, and that can be very helpful for the police organization in terms of identifying what they're doing differently across the geography that they're policing, and trying to identify good practice and bad practice, and those kind of things. I'm sure that David might also have something to say about this.
Not much. No, I think that Juanjo mentioned the main points. Just to add, in the case of London, we've been told that the police are interested in that, and the police are interested in knowing within each local authority which are the most problematic neighborhoods, in terms of police legitimacy and confidence in the police and so on. So, of course, currently the police, what they do is produce estimates at the level of local authorities, which in London are very, very big. But then they don't know if inside each local authority there's very heterogeneous estimates, and that may indicate that in some areas the problem is much more larger than in others. So we know that in terms of policing, they are interested in that, and they want to use it to take policing operational decisions at the neighborhood level.
Great, thank you. I will start now with some questions, more of a technical discussion. So I have here, actually, the sample size is an issue in statistical inference. And there are two questions about that. One, what would you recommend about conducting statistical inference when the study is based on small area estimation? And the second one is, do you think the resampling techniques methods such as bootstrap can help?
So I understand the question. I guess it's asking whether we can use small area estimates coming from model-based small area estimation to then estimate linear models or different types of modeling approaches. And that's problematic, and there's ongoing research about that, because of course each estimate has a measure of error, and we need to account for this somehow in the models, and we still don't know how to do that. So far, what we can do is produce estimates and use it for policy making when they are reliable, and to assist the police, to assist our theories, and so on. But then using them for regression modeling becomes a problem. And yes, I would say that Bootstrap can be a promising approach to try to mitigate the effect of those errors in our small area estimates in the regression models, but we don't know. And we need new research about that. And I am aware that there's research going on in this area, and which is basically done by mathematicians and economists. This is absolutely out of our expertise, but yeah, I would say that Bootstrap is being explored as one potential area to use small area estimates for further analyzing other outcomes.
Okay, thank you. I have a lot of questions of Gustavo Mata, so I will start with them because he will think that I am not allowing him to speak, but no, it's that I have a lot of questions. The first one is, he asks whether it is valid to make a small area estimate with information gathered from previous surveys, using regressive variables from a census made 10 years ago, for example. And then he asks, in the survey information, there are small areas from which it is not possible to obtain the variance, absence of primary sampling units. Is it valid to obtain this missing variance using a linear model or a smooth curve as prediction model? Well, it's a little bit related to the last one. So could you answer this, please?
Yeah, Gustavo wants to make us sweat a little bit, but we'll try to answer. So in relation to the first one, I didn't fully understand the first question, to be fair. So I can start by answering the second one, and then maybe we can go back to the first one, or if you can read again.
The first one was related whether it is valid to use information gathered, for example, 10 years ago.
Yeah, that will depend on the level of variability of that measure, right? So if we know that poverty is very stable over time, and we can prove it with our data, then it shouldn't be highly problematic to use these measures that are not that have high levels of linear trends over time. That shouldn't be a major problem. But if we have if we want to use some covariates that we know very, very much across time, then of course that's more likely to be a problem. That's what I would say, but this of course needs to be guided by theory. I don't know if Juanjo wants to say something else about that. Yeah, and then the second question was about the variance of the direct estimate. Such a good question. Like that's the basis of a small area estimation, right? To have an accurate and a good measure of variance for the direct estimates, which then allows you to combine it with the synthetic estimates. And there's a lot of research again about that. I know that smoothing is being explored, and there's a reason. There's a reason for that. Of course, like it's very important to have a good measure of variance that allows you to combine both components of the EVLAB, right? The direct estimate and the synthetic estimate. But in many cases, we have samples that are so small that the variance becomes very, very, very large, or as he says, sometimes it cannot even be computed. And therefore, when we want to combine them linearly, we end up with synthetic estimates. We give all the strength to the synthetic estimate and we forget all the valuable information that was coming from the survey. And that happens in reality a lot of times. So I remember 3 years ago, probably when I started doing this, our other co-author, my second supervisor, Natalie Shlomo, mentioning smoothing as a way to solve this problem. In any of our applications, we encountered this. We had samples that were large enough to allow us to calculate the variance in all areas in a way that then allow us also to produce this linear combination of both components of the Fay-Herriot model. So we didn't encounter this problem personally, but I am aware that this is a problem in the small area estimation and people are exploring smoothing as a way to smooth the problem.
And related, Marco Antonio Rosas asks whether you have tried analyzing data with areas based on networks of homogeneous geometric figures, such as hexagons. Have you tried?
No, we haven't. And there's a reason for that. That's a very valuable approach, right? Like if you could have information of where, for instance, people live at the level of longitude and latitude, then you can create hexagons, and in theory, you should be able to produce small area estimates. The problem comes when you need covariates, right? And usually covariates are not produced at the level of hexagons. Covariates are recorded at the level of neighborhoods, which are physical or political barriers, if you wish. But then how do you divide the covariates recorded at the neighborhood level in hexagons? You need to reweight it somehow to make sure that the way in which you cut them in half adjusts to the reality and adjusts also to your sample. That becomes a problem. So no, we haven't done that, and I don't know anyone else who has done it. So welcome to join the small area estimation team and try.
Well, but he just gave us a good reason for not doing it like that. So I think they could do something else. So there is another question that says, verification of the hypothesis of the Buil-Gil model, the normality of the random and residual effects, homoscedasticity and the residuals, non-collinearity between the auxiliary variables is strictly necessary, or some of them could be relaxed. For example, in the case of normality, would it be sufficient for the distribution to be approximately symmetric?
Those are questions that need to be answered with simulation studies. In our case, what we did was apply the methods and then calculate measures of goodness of fit to make sure that, and also model diagnostics to make sure that those all those hypotheses were still fulfilled in our case. I don't know how robust the methods are in terms of distributions which are a little bit skewed. So these are answers that need to be these are questions that need to be answered using simulation studies that we haven't done. But again, very good questions.
And then again, Gustavo Mata, it's asking, I think you should talk with him. Gustavo, you should talk right now. So he says, I calculate a first model with 1,000 small areas and I obtain 1,000 residuals. From these residuals, I obtain Mahalanobis distances and discriminate 200 small areas according to the value of these distances. Afterwards, I calculate a second model with the remaining 800 small areas. In the first model, the assumptions of normality and homoscedasticity are not approved. In the second model, the assumptions of normality and homoscedasticity are approved. Is the second model valid?
I don't know, Juanjo, if you have an answer for that. I don't know what to say. I don't know what to say. It sounds like a machine learning approach almost, right? Like dividing your sample in two and then estimating the model in one sample and then testing it in the other approach. I don't know. I don't know what to answer to this. We haven't encountered the problem. We didn't divide our sample of areas into a smaller sample of areas. We just produced estimates for all areas of interest, and we didn't encounter problems of this type of issues.
Okay. So Gustavo, if you want to write something else to clarify or say something back, that would be nice.
No, thank you. Thank you for your. I understand this question is very difficult to respond. For the last question, I understand the problem, and thank you for all. Thank you.
No, thank you. We just have 5 more minutes, but I was reading as well your other works you have, and you work as well in perception of crime. And I was really interested in that because there are level and types of crimes. It's not necessarily the same of having a graffiti than having having really stolen gasoline or an organized crime in a certain area. So I was just curious to know whether you have been able to make a formal contrast in the results of crime perception given different town structures. And if yes, what did you find?
In terms of the perception, if we disaggregate it by the type of perception.
Yes.
I don't think that did we do any of that. That was the first paper that we worked on. That was like 100 years ago. Do you remember if we? I think that we. I think that we
in one of the papers we did, in the other not. So we did one application on perceptions of neighborhood disorder, and what we did in that one is computing a single latent score of perceptions of all neighborhood disorder in Manchester. But then we were also estimating at the level of Europe worry about crime, and then we split it in worry about violent crime and worry about property crime. And yeah, as expected, measures of crime, for instance, have different effect on different types of worry about crime. That was one of the cases. But for most variables of social and demographic, covariates in our case had the same effect in both types of worry. Also, I must say that both types of worry were very much highly intercorrelated between them. So yeah, we were expecting most covariates to have the same effect in both types of worry.
Yeah, that's very interesting. I think that you have a lot of work to do ahead of you, and you should try to use data from Latin America instead of Manchester, of the UK or Europe, which is a little bit nicer. You have to fight with our data. That would be interesting. I think Juanjo thinks that as well.
Well, trust me, data from Spain can also be tricky to work with. I mean, and one thing that we are definitely trying to do is to link up with more people from Latin America doing quantitative criminology. So keep looking at our website for more info on that.
Yeah, I mean, if you data that it's really reliable in Mexico, of course, is done by INEGI. And we also have the National Center of Criminology that we have students from Tec de Monterrey who are working there at research. So maybe we could do a nice link and you can have some nice data there.
Sure.
Is there any other question? I'm reading, huh? I'm sorry. I have to be looking at different screens. Yes, there's another question here. Are there any links between spatial considerations and broader institutional frameworks, national or subnational?
I'm not sure I understand the question.
Me neither.
Hugo, do you want to say something more? That if there, what I understand is that they are asking whether there are links between the results that you have seen with the spatial models and some other institutional frameworks in type of institutions linked with the geographical and the space considerations.
So, like, whether there's some sort of official institution trying to also do small area estimation of related
or where
variables.
there is an impact of type of institutions of the place and the results you have had. The strong institutions, whether versus weak institutions, or whether, I don't know, whether there's some kind of organization like if the country it's as a federation versus a republic or a monarchy, or type of institutions with the type of results you have had.
One example is the networks in the communities. By example,
yeah,
social communities and social networks and something like that around the community. Nationals,
excellent
international,
question.
yes.
Thank you, Hugo, and also thank you very much, Grisel, for all the communication. No, we haven't, and there's a reason for that. Of course, in criminology, we're very much interested in variables such as social cohesion, collective efficacy, also perceptions of democracy and others in the case of worry about crime, but those variables come from surveys. And therefore, having an estimate at the level of areas that we will then use as a covariate would introduce more error in the model because the estimate will have associated error. So it would be amazing. Like, it would be great if we had a measure of collective efficacy, social cohesion, perceptions of democracy, again, all this type of very useful indicators in criminology that criminological researchers use all the time without any type of error in areas. That would be awesome, and then we would apply it in our models. But since they also come mostly from samples, it's risky to introduce them in small area estimation because they could create more error to our final estimates. If that makes sense.
Yes, it did. Thank you very much.
Yeah, just to follow up on that, I mean,
yes.
One of the things that is interesting, and is something that we haven't done, but maybe we could try at some point, because sometimes censuses surprise you, and they have questions that you don't expect to be there. For example, in one of the last senior censuses in Spain, there was actually information about some of the perceptions of disorder in the local community. So that's something that you typically don't find in a census. So though I totally agree with what David was saying, you know, I think sometimes when you scratch beneath the surface, you can be surprised of what's available out there in terms of sometimes this is information.
Juanjo, David, thank you very much. We are running out of time, and we have a second conference coming at 10 o'clock. So thank you very much. It was very interesting to have you here and to know different techniques that are not usually the ones we hear or we use. So thank you very much. Thank you all our audience, and we invite you to follow up with the conference at 10 o'clock called New Forms of Data for Public Safety. And well, see you in 5 minutes. And thank you, Juanjo. Thank you, David, again.
Thank you very much.